Hello students, welcome to the world of chemistry. This is Dr. Vikram Panchal and I'm dealing with chemistry spectroscopy. This is ultraviolet spectra and lecture number 22. In this lecture I will explain you in continuation electronic transition, that is Pi2 Pistar transition. Normally Pi2 Pistar transition is possible when there is unsaturation. So it is mainly for unsaturated compound. So unsaturated organic compounds have weak pi bond comparatively. So if ultraviolet visible light or radiations normally greater than 200 nanometer is absorbed by pi bonding molecular orbital electron, then it will transfer to pi star, anti-bonding molecular orbital. And this is known as Pi2 Pistar transition. Let us see the figure. Carbon and carbon may have double bond. Then there are two pi electrons. When these electrons absorb ultraviolet radiations, then one of these pi electron will shift to pi star orbital and show Pi2 Pistar transition, where sigma bonding electron remain as it is, but one electron from pi bonding transfer to pi star anti-bonding of same molecule. This require normally 200 or greater than 200 nanometer wavelength radiations. Now with figures, carbon and carbon has single bond, that is sigma bond, as well as double bond, that is pi bond. These orbitals are pi BMO orbitals, where you will find at least two electrons, and these are ABMO of pi bond. So we call them pi star orbital of ABMO. This is also pi star. So when electron absorb ultraviolet radiations, one of these electron absorb these radiations and transfer to pi star orbital. So only one electron left in pi orbital and one transfer to pi star. So this is known as Pi2 Pistar transition. Okay, so from Pi2 Pistar transition is this one. As pi bond is weak, the energy required for this transition is comparatively less than sigma to sigma star transition as well as n to sigma star transition. Okay, so therefore radiations, UV visible radiations of higher wavelength is required if number of pi bonds in alternate position are more. It is known as conjugated pi bond or conjugated system. Then resonance stabilizes the system and as energy decreased, the absorption wavelength increases, which will lead to increase in value of lambda maximum. Okay. Example, if we take ethylene, ethylene has only one pi bond, so only one pi to pi star transition is possible, and highest absorption, that is lambda maxima, will be 175 nanometer, which is less than 200 nanometer. But if there is conjugation, sorry, in pi bonding, for example 1,3-butadiene, there are two alternate pi bonds, and here we have a diene system. This is called diene system. So the value of lambda maxima would be about 215 nanometer, and this is also known as base value. UV visible spectra is mainly for more than one alternate pi bonds, that is conjugated systems. So normally we take UV visible spectra of those unsaturated compounds in which we should have at least two alternate pi bonds or more than two alternate pi bonds, not a single bond. Okay, so this is our main system. Now, with reference to this, if we take hexatriene, where there are three alternate pi bonds, again the basic system remains diene and with extended double bond, then obviously resonance will be more, and therefore total absorption also increased, and we can see 250 nanometer. So around 250 nanometer you will find absorption of this molecule, and this is because of the presence of more than two alternate pi bonds. Similarly, if we see aromatic systems, this is benzene. It has three alternate pi bonds. Then we can take naphthalene, which has five alternate pi bonds. And we can take anthracene with three rings, and it has seven alternate pi bonds. As number of alternate pi bonds increase, resonance increases, therefore absorption wavelength also increased. So lambda maxima of benzene would be nearly 255 nanometer, and if we see anthracene, it is nearly 268 nanometer, while in case of naphthalene is having 268 nanometer, while in case of anthracene, the absorption wavelength is about 355 nanometer. So this is because of alternate double bonds. So when molecule has more than one pi bonds, then we will observe Pi2 Pistar transition, and this type of transition is very, very important for studying UV visible spectra. So this is very important for us. Thank you so much. That is it in this lecture.